Um, a lot of people just ask me like how to find a limit of a function. So here are some of the example that I choose for today. So the first problem is that we need to find a limit of x goes to 1 of x cubed minus 1 over 2x minus 1. If we just simply replace x equal 1 here, so we're gonna have 1 minus 1 over 1 minus 1, which is 0 over 2, 0. So we cannot find the limit of 0 divided by 0, right? So we need to do some manipulation so we can look at the denominator. First of all, we need to write limit x goes to 1. So in the denominator, we can write like this for x cubed minus 1, right? And then just divided by x1. So we can simply cross out the x minus 1 right here. So the limit x goes to 1 is gonna be x squared plus x plus 1. So we just simply replace 1 to x. So we have 1 plus 1 plus 1 equal to 3. So the limit of this function is 3 when x goes to 1. So in the problem B, if we just replace or substitute x equal to negative 3, okay, so we can try negative 3 squared, it's gonna be 9 minus negative 3 minus 6, so this is gonna be 0. And negative 3 plus 3, it's also 0. So we cannot find by just simply substitute x equal to negative 3, right? So we need to do something different. X goes to negative 3. So look at the denominator. We actually can find x squared plus x minus 6 equal to 0. So we can see x equal to negative 3 and x equal to 2. So in the denominator, we can write like x plus 3 times x minus 2 divided by x plus 3, right? So here once again we can cross out x plus 3. So now the limit x go to negative 3 of x minus 2. So we have negative 3 minus 2 equal to negative 5. Okay, so the final answer is negative 5. Let's use a red color here, okay? So the problem C, if we just plug in 0 right here, so we have 0 plus 1 minus 1, 0. Once again, it's going to be 0 over to 0. So we cannot do this way. Now, we can't limit x go to 0. So x plus 1 minus 1, we can multiply with this plus 1, and then also the denominator we also have to multiply with the same. Alright, so here the limit of x go to 0, so we're gonna have square root of x plus 1 square minus 1 square divided by x times square root of x plus 1 plus 1, like this. So the limit x go to 0, and then the denominator we can see is x plus 1 minus 1 x times x plus 1 plus 1. So we can simply cross out, let me use another color, x right here, 1 1. Alright, so the limit x go to 0 of 1 over 2 square root of x plus 1 plus 1. Now we can plug in 0 to x, and the final answer is gonna be 1 over 2 square root of 0 plus 1 plus 1. So we have 1 over 2. Here is our final answer. So the limit of this function when x goes to 0 is 1 over 2. And problem D. Alright. Problem D. So we have limit of the tangent of x go to 0, right? So the tangent x is gonna be equal to sine x divided by cosine x. It's gonna be, so if we x go to 0, which means sine 0 divided by cosine 0, which is gonna be 0 over 1, it's 0. Alright, but the limit of x go to 0, so we have tangent x go to x, and tangent x actually 0, right? Can you see? It's gonna be 0 over to 0. So this way, we cannot do this. We need to do a little bit different. So we're gonna eliminate this cut. Alright. So here the limit x to 0, so we can write it x go to 0, sine x divided by x times 1 divided by cosine x, and this limit of sine x divided by x is gonna be equal to 1. And then now we only have to do limit of x go to 0 of 1 over 2 cosine x is gonna be limit x go to 0 of 1 divided by cosine 0. And remember, cosine 0 is equal to 1, so it's 1 over 1. So the final answer for this is gonna be 1. Alright.